Good evening, everyone. Thank you for making it to the last session of KubeCon, and hopefully the next 30 minutes will be of some value to all of you. As for the agenda today, we'll start off with a quick round of introduction of all the speakers. We'll go over what Containerd is and what the high-level architecture looks like. We'll do a quick recap of the latest 2.1 release and discuss what the new release cadence, LTSC model, and the KEP process looks like. We'll set some expectations for the next 2.2 release, which is slated to go out in November this year, and also discuss file systems, snapshotters, and node resource interfaces. We'll then transition over to maintainer panel discussion, where we go over some of the frequently asked questions. As for me, I'm Kirtana. I work for the container platform team at Microsoft, and we're responsible for enabling containers to run on Windows.
Let us introduce ourselves. I'm Akihiro Suda from NTT Corporation.
I'm Kohei Tokunaga from NTT Corporation.
I'm Akhil Mohan. I work at VMware by Broadcom, and also a Containerd reviewer and maintainer.
Right. What is Containerd? Like most of us here already know, it's a high-level container runtime that is responsible for running and managing your containers. And it has a very modular and plugin-friendly architecture, which allows you to extend the functionality by defining your own custom plugins. At the very high level, some of the primary interfaces that you can use to talk to Containerd are the gRPC APIs. For example, CRY that Kubernetes uses. Containerd has its own Go client library that you can use to interact with Containerd, and there are other command line interface tools like nerdctl. At the very core, Containerd is a collection of microservices, like your content service, image service, snapshot service, and the like. And we also have a metadata layer that stores metadata of these components. And ultimately, Containerd uses the task service API to talk to low-level container runtimes like run-etc, etc-shim, and run-wazi. Some of the examples of custom plugins are like the lazy loading snapshotter that we'll talk about towards the end of the presentation. We have nerdctl on the client side, and we also have run-wazi, which is a low-level container runtime for WASM workloads. 2.1 was the latest release of Containerd that went out in May, and it was the first release after the new release cadence was also defined. We'll go over some of the key features that made it to 2.1. Firstly, there was support added for the enhanced read-only file system. This is a lightweight, very performant file system developed by Huawei, and has been proven to be very efficient for container images with many layers. Support was also added for image volumes, and this feature allows you to mount a container image as a Kubernetes volume. For example, now you can start sharing your config images, binary artifacts, and machine learning models between containers in your pod. And this way, you can separate your data image from your code image. Writable C group support existed only for privileged containers, and this was extended for non-privileged containers in the 2.1 release as well. And support was also added to allow multiple user ID, group ID entries to be added to your user namespaces. And apart from this, we have also transitioned to using transfer service as default for the CRY image pools. And container restore support was also added through CRY. And some other deprecated features like the Docker Schema 1 images and Go plugins, which were deprecated in the previous releases, have now been removed. What is the new Containerd release cadence that we have defined? The community intends to now release a new minor version every 6 months, and roughly around 10 weeks before the actual release is supposed to go out, we'll have the beta versions go out. And roughly a month before the release, we are hoping to have the RC releases go out as well. So for example, the 2.1 release went out in May this year. So the next one will be the 2.2 release approximately in November this year. So roughly around September, we'll have the beta tags go out, and in October, we'll have the RC releases go out as well. And next, I'll hand it over to Akihiro to take over the next few topics.
Hi, let me talk about long-term support model. So for long-term support releases, we still do not have a periodic cadence. But we will promote existing short-term release to long-term release when some branch maintainers step in to maintain the branch for 2 years at least. But the period can be longer at the will of the branch owner maintainers. And currently, we have version 1.6 and 1.7 as the long-term supported releases. And 1.6 will reach the end of life just next month. But we have already supported more than 3 years for version 1.6 LTS. So the current latest long-term support release is version 1.7, which will be maintained until March next year. And we still don't have LTS for continuity version 2, but we will determine version 2 LTS probably in the next couple of months. And we also improved the KEP process. KEP means Kubernetes Enhancement Proposals submitted to the Kubernetes upstream. But this model had some problems. So the visibility of the proposals were poor. So some proposals didn't get much attention, and sometimes they just got forgotten. And we lacked communication across the Kubernetes maintainers and continuity maintainers. So we made some improvements recently. So we began to track proposals in the continuity repo, as well as in the Kubernetes repo. And we began to assign KEP shepherd continuity maintainers to help moving pull requests along. And we also added the role of signal liaison continuity maintainer to improve the communication across continuity and the Kubernetes signals. And here is expectation in version 2.2 in November. This is just tentative. Some features may be not implemented in version 2.2 or maybe postponed to 2.3. But as a tentative list of the features, we plan to support Kirtana for file system snapshots, such as overlay FS. And probably we have a new mount management interface with the garbage collection algorithms. And for the CRI plugin, we'll have poseless port sandboxes so as to eliminate the dependency of the create_s.io/port image. And also for the CRI, we have image pool for runtime classes, such as gvisor or kata or RASM. And for NAD CTL, continuity CTL command line interface, we will support health check instruction of Docker file for better compatibility with Docker. And Kohei will talk about continuity snapshotters.
Okay, so in the latest release, we got updates on snapshot component. So snapshot component is one of the actively developed components in Containerd. And so I'm gonna deep dive into Containerd snapshotter from this slide. Snapshotter is a plugin to manage unpacked image layers. These layers are called snapshots, and it supports a variety of file systems, including overlay FS, Evo FS, which is recently added, and ButterFS, device map, etc. And as shown in the figure, the layers are pulled into Containerd's content store. Then these layer blobs are unpacked into snapshot. And snapshots can be used as the root file system of the containers. And one of the built-in snapshotters in Containerd is Overlay FS snapshotter. This uses Linux Overlay FS to stack layers, and this is the default snapshot on Linux. As shown in the figure, when pulling an image, unpacker component creates an active snapshot which provides a writable mount, and the unpacker writes the layer on the snapshot. This snapshot can be committed and used as a parent of another active snapshot. Containerd uses these snapshots as the root file system of the containers. And Containerd is extensible, and you can bring your own snapshot implementation, and there are implementations developed in the community as listed in this slide. And one of the snapshot implementations in the community is StarGZ snapshotter. This supports lazy playing technique. This is an image distribution technique that allows Containerd to start a container before the image is fully downloaded on the node, so it improves cold start performance. It uses a OCI-compatible StarGZ image format. This image is fuse-mounted from the registry directly to the node. And Containerd can use these StarGZ mounts instead of fully pulling and unpacking layers on the node. And this is a detail of a StarGZ image format. This is an OCI-compatible format. This is an extended version of Google's StarGZ image format by CRFS project for supporting prefetching. And this is a 100% compatible to the current OCI image format. So it means you can use StarGZ image even on runtime that is not aware of StarGZ image format. As shown in the figure, StarGZ applies gzip compression per file to allow separately fetching and decompressing each file. And prefetching is done by putting all the prefetching target files into the top of the archive so that they can be fetched by a single range request on startup. And this graph shows the performance improvement of cold starting of a container. From the topmost, it measures the startup performance of legacy OCI image, and StarGZ without prefetch optimization, and StarGZ with applying prefetch optimization. And this graph shows by applying StarGZ image format, cold start performance can be improved a lot. And also by applying prefetch optimization, the performance improves further. So yeah, next.
So now we will take a look into Node Resource Interface, or NRI. NRI is like a component in Containerd that actually helps to modify the container, modify the behavior of the container on various container lifecycle events like a container start or port start, etc. So basically, you can add custom logic or vendor-specific logic to inject like GPU devices or like resource control functionality into the container without modifying the core runtime code. So it's like actually NRI works by extensively by using NRI plugins. So this is like a rough architecture of how NRI works. So whenever from kubelet you get a create container request, the Containerd CRI plugin receives it and converts it into the OCI spec. And this OCI spec is adjusted by the NRI plugin. There will be like various plugins that makes like adjustments to the OCI spec, and then finally the modified OCI spec will be used by the runtime to create the container. So this is the configuration of how you provide like NRI in containerd, and this comes under the default containerd configuration. From containerd 2.0 onwards, like NRI is enabled by default. You can provide like various flags like which all directories we have to scan for like possible NRI plugins, and if you have to provide any custom plugin specific configuration along with the main containerd configuration. So now let's look a little more deeper into NRI. So NRI has like 3 core components. The first one is like the NRI API, the protocol buffer that is like defined, and then we have the NRI Golang library that is used by the runtime to integrate with NRI, and then we have the client package that is used by the NRI, that can be used by NRI plugin authors and NRI plugins to basically integrate with NRI. And the NRI API provides 2 services like the runtime service and plugin service, which can be used for like various functions to initiate the registration of a plugin and get the list of running containers, also like request modification to containers and ports, etc. And the plugins and the runtime communicate over an NRI socket that like we have previously defined in the configuration. So now let's take a look at like some of the sample plugins that containerd already maintains in the containerd NRI repo. So first one, like I'll look into like the ulimit adjuster. This plugin helps you to adjust the ulimit values of the container, like your memory lock or like the number of open FDs in the container. This can be adjusted using port annotations. And then we have like the network device injector. So there can be use cases where you want a specific network interface available to just one single port. In that case, via port annotations, the network interface can be specified, and that interface will be specifically available in that port. And then you have device injector. Device injector helps you to add or Linux device nodes or like CDI, container device interface devices, or like mounts inside the container or port, and again via the port annotations. And so now let's look at like what are we planning for the future of NRI, or what are the features that we want in like NRI 1.0. First one will be like policy controls. Since NRI plugins can modify the OCI spec, we need to make sure that there is some certain set of validation and policy available so that the modified spec does not compromise the isolation that the container provides. So that is like one step that we want to add in like NRI. And the next one is like improved observability. So currently the logging in containerd from NRI is not that great. So and also like along with the we need to keep a track of what are all the adjustments that has been done in the OCI spec by the NRI plugins. So we have an audit log of what changes went in, and also can check on like what are the NRI plugin failures that happened due to the adjustment and the latencies that has been there. And then is the consistent failure characteristics. So this means like that all the NRI plugins, the authors need to expect a specific failure, how the NRI plugins might fail. So if you have like multiple NRI plugins that work in like at different stages, we need to make sure that like an error in an early stage plugin does not affect or like how it will affect it or skip the execution of like the next stage plugins that are coming. And yeah, that's it. Over to Kirtana.
We'll now go over a quick panel discussion of the most commonly asked questions we get. So the first one is, how did you get involved in containerd? Do any of you want to start? Okay.
I can start maybe. So I started from working on Snapshot plugin. That was in 2020. 2020 I started the Snapshot project, and it is added to containerd as a non-core subproject. And since then, I've been working on image distribution logics and snapshot logics. And in 2021, I became a reviewer of Containerd. And since then, again, I've been working on mainly on image distribution logic or image converter logic. Yeah, this is one.
For my years, I have been a maintainer of Docker, also known as Moby, since 2016. So it was inevitable for me to contribute to Containerd because Docker is built upon the Containerd's technology.
I started working on Containerd like somewhere in like 2021. I was actually, I had a side project which was using Containerd underneath, and like it had a few of issues. So eventually to fix them, like I got into the Containerd community, and like that's how like I started learning more about like the image pulling and like all those logic, and I became a reviewer of Containerd in like 2023.
And as for me, my journey with upstream Kubernetes and Containerd mostly started off after I joined the container platform team. And for me, my journey was mostly looking into the GitHub issues, looking at the ones that were tagged as first issues and other smaller tasks, and I kind of worked my way up from there. And I've been a Containerd maintainer for a little over, I think, a year and a half or 2 years now. So the next one is, what is something you are excited about in the container space?
Yes. I have two topics about this question. One of them is, of course, Snapshotter. Snapshotter is a still actively developed component in Containerd community, and recently EOFS support is added, and this is in-tree snapshot supported as one of the core component of Containerd. So yeah, so I'm really happy to see snapshot component is still actively developed and improved. And another one is introduction of a transfer service. This is a new component for image distribution introduced in Containerd core, and so the difference against like a traditional image distribution logic is that traditionally image distribution, especially like connecting to registry, is done by the client side of Containerd. But by introduction of a transfer service, now image distribution is done by Containerd core, and this is actually a good change from a snapshotter's perspective, especially like an external snapshotter plugin developer's perspective, because before, from the snapshotter perspective, if a snapshotter wants to access to the registry, it needs to get like a registry creds or something. Somehow, and traditionally it is done by patching Containerd client to explicitly like share creds into like a snapshot component, and that is very large maintenance cost. But by introduction of transfer service, now Containerd core completely handles image distribution logic. So I expect this will lead to like a tighter introduction between external snapshot plugins and Containerd core, especially for image distribution logic. Yes, this is my answer.
I'm excited about sandboxing in AI coding. So recently, people began to use AI to generate scripts that can be potentially malicious. So the importance of containers and virtualization is much more important with AI coding. And maybe eventually we have to some standards spec for sandboxing with MCP, model context protocol. And eventually, maybe we have some OCI working group for standardizing running potentially dangerous commands in sandbox like OCI containers.
I'm looking forward to that. Like there is a effort in Kubernetes and containerd community to remove dependency on CAdvisor for the metrics, and for that, like we have CRI metrics. So basically, which are all metrics that we are currently get from CAdvisor, it will be like fetched via CRI and passed on to Kubernetes. So that is something like I am like currently working on and like I'm looking forward to. So basically, it will remove a lot of dependency tree, like dependency chain in like both kubelet side as Kubernetes as well as containerd. Yeah.
And as for me, I'm mostly looking forward to the image pull per runtime class feature to go out as part of 2.2. And once this feature has been shipped, it'll basically allow users to pull an image for a given platform rather than defaulting to the platform of your host. And some of the use cases would be the virtualization-based containers like Kata containers and Hyper-V-based Windows containers. They would really benefit from this feature. So yeah, that's something I'm looking forward to in the next release. I think we have a few more minutes, but as far as our presentation goes, this is what we had. Maybe we can open the floor up for questions, if anyone has. Yeah.
Yeah, thank you very much for your talk. I have a question. How much time do you usually spend on maintaining containerd, like your spare time? And do you experience any burnout using, working on your main job and maintaining side project like containerd?
I think it's been different for different maintainers. Some of them definitely contribute a whole lot of time maintaining the project. I can speak for myself. I think for me, it's mostly been on projects that need Windows support as well on containerd. It's mostly, I don't think I can draw a line in percentage-wise, but mostly it's outside of my work whenever possible, additional work. But for the rest of you guys, do you have any thoughts?
For me, like, I actually have that separation, like keep that separation so that like work and like the open source one, like I can keep it separate. But like as for my day job also, I'm like pretty involved in the like the SIG node and like the containerd aspect of things. So still like some of the open source work I do at that time also. But like mostly it's like most of the feature development and core things like I do like after work. Like that separation is there. Only like things that are like business impacting, I do it that way. Yeah.
For me, I'm writing open source projects as a full-time job, but I'm managing too many open source projects. So for containerd, I'm just dedicating about 20 or 30% of my working time.
I'm also working on open source project as part of my job, and and I also work on several open source projects. So yeah, I allocate the time to those projects.
First of all, thank you very much for your contribution and amazing speech. I have a funny question. What do you think, guys, what will be containerd? So what is the future of containerd and can it be replaced?
Can it be replaced? I mean, time will tell, I guess. But as for the future, I think if you're talking in terms of the next few releases, it's the ones that Akihiro presented here.
So for our containerd version 2.2, can you show the slides?
The 2.2.
Yeah, so we have some plan about mount management and file system quota, and other improvements in CRY. And probably we can add more features. So please feel free to submit your proposals. And I also mentioned that as with the evolve of the AI, maybe we will try to find out how we can integrate MCP or anything similar to continuity, or maybe a more higher level, like NASCP or maybe Kubernetes. We still don't know, but we will investigate that.
So we're sorry we have not enough time so that we can accept any more questions. So if you have more questions, please ask them directly after the session ends.
Right. Yeah. Thank you, everyone.